Cool. So E3D, this is the big one this year. Sanjay, thanks for having me. Before that, thank you to Matter Hackers and Ultimaker for making this trip possible. But you've got something big. We're gonna get to that in a second. Before that, you've got a few like iterative things that you're just improving to the product you already have. So what's going on there?
Yeah, so V6 has been a product that's been out for years, right?
Yeah.
But V6, when it was launched, and V6 now are like totally different things. Every single component has been completely redesigned and remanufactured in different ways, like everything. The heat sinks, much higher tolerance. We integrate the coupling into them. The heater blocks are way better in how they're machined, and we've changed the alloy to be more conductive. We've adjusted the screws so that the heads don't strip and little things like that make it just nicer to use. We also have the copper nozzles for high temperature applications. We are announcing today that we are about to release a new coating for our hardened steel nozzles. So our hardened steel nozzles currently have a black oxide coating on them, which is a bit like plastic likes to stick to it. It's not great. The new coating it's like super polyphobic, if you like. So we tried Teflon. Teflon, when it's hot, plastic still sticks to it. We tried a million things. We've come up with this coating. We're not going to say what it is until we launch it. But it's really cool. So if you're like printing a layer that has tracks like this, and you do that and come back, often this wants to peel up because the nozzle drags it. Not with this, because it goes down and the plastic doesn't want to stick to the nozzle.
It's literally laying it down.
Yeah. And your top surface layers are like glass. Like, it's really, really freaking cool.
Okay, I gotta see that in action.
Yeah, and we can also apply this coating to the socks, we think. And the blocks. And maybe even inside the heat breaks.
Yeah, and on the topic of the heat breaks and stuff, so you've announced yesterday that you've made some major improvements on just manufacturing of nozzles, heat breaks, just all those details are now better?
Yeah, so I'm like big machining nerd, so we're achieving 1.4 micron RA on the inside of the surface finish. So in layman's terms, that's near mirror finish. We actually found that if you go too smooth, the polymer begins to stick, so we have an engineered amount of roughness on the inside.
It's amazing how much attention to detail goes into these. And you've mentioned that you're now actually selling to China instead of having it the other way around. I think that's a pretty good achievement. How is that happening?
I'm sorry, can't say. But
it is.
We make great products. They want to make great products. Lots of manufacturers use E3D parts that don't look like E3D parts for obvious reasons. But yeah, that's a big part of our business. I can't disclose who and what they are.
Obviously.
It's more than one as well, so that's multiple.
Congratulations. So let's just take a quick walk through what else you have here. So
yeah, we'll do the run through fast, right?
Yeah, let's go speed round.
All right. Okay. So water-cooled Titan, which is for printing high-temperature materials inside high-temperature environments.
Okay, that is officially released and announced now?
Yeah. You can buy that online right now. It's like 140 quid. Maximum operating temperature for that is about 120 degrees because the Delrin gears and idler begin to get sloppy. If people want to go hotter, we can run them in peak. But what we have here is the water-cooled Cyclops or Chimera. It's also basically our water-cooled V6. So we sell it with one hot side, one nozzle and one heater block, because we found that we actually couldn't cut much weight by making a single one, so we may as well just make doubles and sell it with just one. And that gives people the opportunity to upgrade in the future. The cool thing about this one is there's no Delrin anywhere.
So this is high temperature up to a lot.
Yeah, basically. We've run it at 300 degrees in an oven for a few hundred hours. It's good. I don't know how hot it could go. Because as long as you lag the as long as you lag the couplings and the tube together inside of a sleeve, a silicon glass fiber sleeve, then the water cooling cools everything inside.
Yeah, exactly. It does have continuous water flow to it, so it's cooling itself.
The only vulnerable parts of the Molex microfit connector and the coupling that holds the tube. But you can get both of those things like right on the water-cooled heatsink and insulated from the environment. So you can run the thing at 300, no drama.
Wow.
Yeah.
Okay. That's your standard product.
Yeah. Also,
this is
air cooled as well.
Okay. Yeah. So that's just the new version of the Chimera and Cyclops.
And if you want to be crazy, we've actually made the heat break spacing such that you can put 2 Cyclopses into a Kraken. And
so does the Kraken still exist?
Yeah, it still exists. Okay. It's being overhauled as well to be updated to the new tubing and the water cooling kit, and it just needs a small overhaul. But yeah, the Kraken's a crazy product. It's like a Bugatti Veyron. It's totally impractical. It's to show off what we can do as a company.
You make it just because.
Exactly.
Okay. But let's move on to. We know these.
Yeah, we said hot ends.
Can we show the Super Volcano?
Oh yeah. Where's the Super Volcano? Give me a second.
The Super Volcano.
Yeah,
you've got quite the long
melt zone there. That's one approach we're looking at. We have another approach that we're looking at that doesn't require such a long melt zone. I don't want to go into the details of that, but
we've discussed that before.
Yeah. So that's going to be cool. Very hard to manufacture, but it's going to be cool. So Sam over here is the chief developer of this product, and it's about to go out to our beta testers for beta testing. So it should be released in about a few weeks to a few months, depending on how their testing goes.
All right. So right now, this can people buy this? This is like a double-length volcano.
No, you can't buy this right now because it's not finished and it's not tested. We like to test our products and
I guess that's a good approach. Yeah?
To check that they work. It's kind of novel in this industry, but we kind of like to check and do quality control and testing and things like that. It's very unique to the 3D printing industry. But yeah, it's a simple product.
This is upcoming, but this is something that you can get excited about.
Yeah, we're actually in a consortium with some other printer manufacturers who have huge printers who want to establish a new standard for 5 or 6 millimeter filament. And we want to develop extruders for that and so on and so forth. But what's really cool is we're like all the manufacturers of these printers have gotten together and created a consortium, and we're going to have an open standard. So we're not going to have this like 3mm 285 nonsense again. It's going to be done properly, and it's going to be intercompatible so that everyone just, you're not restricted to a particular manufacturer's materials, which I think is a really cool approach, and we're excited about that.
That's the right way to go about it.
Yeah.
Okay, that is your standard product, I guess. So let's...
Yeah, that's the boring stuff.
Yeah, let's actually get to the non-standard bit over here. Yeah. So, what?
Yeah, okay.
So what?
This has been a dream/passion project of myself and Greg, who's the real hero over here.
Shout out to Greg.
He's the guy that did all the CAD and the assembly. I was he's the Wozniak and I'm the Jobs. I had the idea and guided the process, but really Greg executed it. So the credit should go to Greg. It's 2 things here. One is our concept was, if we have no budget constraints, how badass can we make a 3D printer motion system? Yeah. Money is no object. So we'll talk about that first. And then
is that what this is?
And then we'll get on to the Toolchanger. Okay? So
it's two components to this.
2 things in one. And I don't want to overlook the motion system because it's insane. So we want to come in. This is a Core XY Fab Totem style belt arrangement, which we really like because it keeps all the belts planar. There is a moment that's applied, but it's applied to the head over a very small moment arm, and so we think it's the best implementation. The motors are all static, and the head is on a genuine high wind rail. Genuine high wind rails they're expensive, but oh my god, are they good! They are so much better than the Chinese clones. I didn't expect it, but they are incredible. So we have a micro high wind rail on here, and this is attached to a carbon fiber machined crossbeam.
Basically, yeah.
Yeah, so this crossbar here, this is the largest moving mass. So you want to spend your money reducing that moving mass. So this is machined out of unidirectional carbon fiber.
And it's not that expensive. Like,
No, it's like $100 or something like that for the piece.
for a one-off piece.
Yeah, this is just what we had lying around in terms of carbon fiber. What I want to make it out of is Ultem foam sandwich panel composite, because it only experiences forces in the planar direction, and the weight forces that it takes are very, very minimal. And it's also got the rail attached to it for stiffness in that bending moment. And so all it has to resist is planar bending. And your planar bending force is a fourth power of its dimension. And
So you want to make it thick instead of very thin and stiff.
it weighs 120 grams. I think we can get it down to 60. You have to then add on the rail and the carriage and stuff. But I mean, it moves like feces off a shovel. Like it
might need to censor that for YouTube, but
it moves like hell. It moves like hell.
that's not better.
Very little moving mass, and all the motors are fixed. The Z-axis on this is first prototype. What we're doing for the final production version is we just got the biggest, fattest, widest high wind rail we could find.
So it's a double wide, basically.
It's a double wide, fat-ass high wind rail with a long carriage, and then we're having a bent aluminium cantilevered bed that we've done a lot of FEA on. The bed can support 4 kilos. And with 4 kilos, it will deflect less than 250 microns. So
That's static deflection.
yeah, that's static deflection. And in terms of resonance, it's quite good. So it doesn't, on Ultimakers, if you have them on a wobbly floor and you walk past them, the bed
Especially if you have the extended or even worse, the stretched versions, the stretched clones.
And this doesn't do that. And so this carbon fiber crossbeam is rigid. It's stiff. So stiffness is everything. When it comes to machine design, stiffness is king. So the entire XY motion system is built on a single machined piece of aluminium tooling plate, which is incredibly flat, and in the planar direction, it's basically infinitely stiff for our purposes. We have larger, genuine high wind rails on the back. We're using genuine Gates GT2 RF belt, which is the best belt you can buy.
And versus just a run-of-the-mill Chinese belt, that makes quite the difference.
It makes a huge difference. There's a lot more aramid fiber in there, because the Chinese manufacturers cheap out on the aramid fiber, and also it's how they weave and direct the fiber. There's some witchcraft there. Also, the teeth on these belts are coated in nylon, so they don't wear and you don't get that black dust.
It's not directly the neoprene that's in touch with stuff.
And they just run smoother and quieter. And they're really good. So ringing is, when you go past a corner, you get the ding, 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 ding. It's drastically reduced. It's really, really nice.
But you are still running on belts. You're not using lead screws on X or Y here.
No,
because core XY again.
Lead screw on Z with a big fat high wind rail. We tried ball screw on Z, but we actually found better results with a really high quality lead screw and anti-backlash nut. The lead screw resulted in the ball screw resulted in over constraint and binding issues. So the lead.
You guys have some experience with that, I guess.
Yeah. Oh God, don't please, no. I'm having flashbacks. Yeah. One rail, one lead screw, no wobble. So everything is mounted on cantilever post standoffs. You got to see the back of the machine because it's gorgeous. You got to see the back.
Let's move around here.
So our objectives were, money is no object, but still design for manufacturing, design for assembly. So this is one plate. We have motors here that are on turn standoffs that bolt on. So these are the XY motors that run the core XY system. And then you have the 4 motors that run the tools. and they're running really short cables that go directly into a duet. So very much reduced EMI problems and really easy to wire up.
Yeah, and that looks super clean, I gotta say.
Yeah, it's super clean, really nice. This can be cleaned up a bit, I suppose, but nice power supply. We have a solid state relay in there.
Just in case?
I'll tell you about that. Let's go on to the tool changing now.
I guess, yeah.
So we've got a duet, and big shout out to the duet guys, because this would not be possible without the scriptability and macros and things that you can do with the duet, and also the duet X5 or 6,
So this isn't just the regular duet, which is just this up here, but it's got the extension board on it.
Correct, yeah. And we also have a Raspberry Pi in the front with a camera, and that goes through the web interface through touch, just because we enjoy that a bit more. Yeah. And it was fun. So Greg loves Raspberry Pis. He puts them in everything.
Right. But should we change some tools?
Let's change some tools. All right, so this thing is the kind of king of the whole process. It's a T-bar with ramped cab angles on it, and it rotates. So Greg, can you rotate the... So there's a servo and a 3-to-1 gearing mechanism in there, and this rotates back and forth. And then we have heads. You can just grab the heads. They're magnetically attached to their dock over here, so you can just pop them off. If there's something going wrong with a head during a print, you can just grab it and go and do what you want with it. So on here we have a slot, and so that T-bar enters that slot and rotates. And as it rotates, the surfaces on the T-bar are ramped. So as it rotates, it kind of screws in like a bayonet fitting. This part here is on a spring, and so the spring wants to constantly pull it back. So if I pull on this, it will come out a little bit. But there's a very stiff spring, and the tool has kinematic couplings. Kinematic couplings are a long story, and I won't try and explain them, but go and Google about them. They're amazing. So we can take a head, and this is normally done automatically, but the head gets placed onto the kinematic coupling. The kinematic coupling rotates, and the heads are now attached. And the head attaches with 3 micron accuracy on the current couplings, and the current couplings are handmade aluminium kind of jokey bits. In production, there'll be ground hardened steel surfaces, so we might even see sub-micron pickup accuracy. I've had to buy a better dial gauge, a digital Mitutoyo that goes down to 1 micron. Our error budget was 50 microns, so we've done it by 1 order of magnitude better than we expected, which is cool. The head is positively locked, but it's sprung locked, which is kind of cool. So the printhead has suspension. So if you have a crash, the printhead can move, but it'll always snap back to where it should be within 3 microns. So you can have head crashes and the tool won't detach. The tool can't detach because it's locked in with the T-bar. But it's got the spring on the thing. So we can drop off a tool. I'll put this back on the bed, and Greg can run through picking up some tools automatically. So we've now acquired a tool, and we can put that tool back, and then maybe go off and pick up this tool over here. Now this is in boring mode, because all we have on here is 4 V6s running 4 conventional materials, but that's not really what this is all about. So we could just as easily have this is a hardened steel, high temperature volcano setup that is designed for printing carbon fiber reinforced Ultem.
Yeah, so this obviously has a different length than your regular V6s. Correct. How are you handling that?
That's a tricky one. So we have a dump zone over here, and so we would have to have 2 dump zones, or in the future we might have a dump zone that can move up and down. That we've not really figured out, but it doesn't end at additive tools. So what we've already built is a tool that has a Raspberry Pi Zero and the camera and a macro lens, and so in about 3 seconds you can go grab the camera, you take 6 images all in 3 seconds, 1080p per image, that goes up to a server, and then we need to write a Python script that stitches all the images together and then runs FFmpeg to turn them into a video.
So you're basically just getting a documentation of what every single layer looks like in high resolution, and that might not be something that the typical user needs, but industrial,
love all that stuff. And we can use computer vision packages to compare the G code to the print and look for errors potentially.
And expanding on that, I mean, that's really where the beauty of the Toolchanger lies. Like multi-extrusion, you can do on so many different approaches that all work, or many of which work pretty well. But you're not just picking up more FDM tool hits. You're picking up the cameras. You're picking up. You mentioned subtractive.
Yeah, we're going to do subtractive. We're working on that right now. So we're going to have a milling cutter. Greg's also a big laser guy. He made the first desktop diode laser cutter called the Microslice. So we're going to put a laser on. I'm not really sure what we're going to do with the laser. We think we might be able to do subtractive trimming with certain materials. But at the very least, we could do part marking or serial number marking. And so you could print a small dog bone, like in aerospace, you could print a small dog bone with a serial number etched into it, and print the part with a serial number etched into it, have the full video of it being built, and then you can break the test bar to check that the material and print settings were all good and the material's in spec. You also have the full inspection set of the entire print all the way through. And then you can finish it subtractively. So you can have like a milled or close to machined surface finish and tolerance. We're also developing a pick and place head, which is where things get really exciting.
So pick and place, I mean, I imagine that's for like SMD electronics component placing. You're talking about something that's a bit different, right?
Yeah. So we're talking about picking and placing mechanical vitamins, as we used to call them back in the day. So like bearings, pins, screw inserts, the little press fit inserts for screws. All of these small mechanical components that can't be 3D printed but are necessary parts of products. We don't want to manufacture parts, we want to manufacture products with zero human labor. So what we might do is print a small rack here that holds 608 bearings. So let's say you want to manufacture a fidget spinner.
Why would you want to do that?
As an example, I hate fidget spinners too, but as an example, you could print a rack here that holds 6 or however many 608 bearings. A human comes along and loads, or a robot arm comes along and loads your 608 bearings. Your printer comes along, prints the first half of the fidget spinner, then changes heads to the pick and place head, which is one of those, like the coffee ground balloon suction thing. Yeah. So you can come pick up your bearing, drop it into the pocket, drop them all into the pocket, drop off the pick and place head, go pick up the additive head, continue.
And just keep on going, and you have a finished print that needs, or a finished part that has, both plastic and like vitamins, bearings, screws, etc.
We want to manufacture products, not parts.
And you already briefly talked about like your pick and place is not just a pick and place sponsored by Coke, but it's also more like a grab and drop head as well.
Yeah, oh yeah, okay. So with a great deal of materials and beds and surface finishes, when the printer bed cools down, the part automatically detaches or needs very little force to be able to detach. And so we can then come along with the pick and place head, put it onto the part. We could print a little, if permissible, you could print a little thing on the part for it to grip to. You grab the part and then use momentum and you throw it off into a bin.
I didn't think about momentum yet. You're so right. You could just literally throw it off.
Now things are getting pretty crazy. So we're like printing entire products. So this bin could be a water bath with motion in it to dissolve the soluble support. We're developing a new soluble support as well, which is going to be amazing. We'll talk about that maybe when you come and visit. It's not finished yet. At the moment, we've got this big cable problem. With the rigging, as we call it. We want to get rid of the cables going to the hot ends and replace those with pogo pins, such that the print head
So there's one cable going to the carriage, and that just connects to each head.
And then you have the filament problem, because you still have to have the filament going to the hot end. Instead, what we will have is a dock over here with 10 filament, like Bowden tubes, if you like, with filament on them and a filament loader, much like Joseph Prusa's new filament loading device.
Yeah, we're going to check that out in a second.
So what that will allow you to do is select a head and a material. So you can use any material in any head.
Volcano, regular one.
Yeah, so for example, you could have a spool of carbon fiber reinforced nylon, and you could come along, grab your volcano head, print the structure, your infill, then come along and then maybe you've got some details like you got a small pocket that you need to do really detailed. You come pick up the 0.25 head, you grab the carbon fiber reinforced nylon from the side, from the material dock that we'll put here, and then you print the details with it.
Yeah, but probably you don't want to print it with a 0.25, right? Fiber reinforced stuff?
Yeah, I suppose that's a bad example. You're right. But you could just print with a normal nylon or any other compatible material. We've been printing gears. Our gears here are carbon fiber reinforced nylon for the spokes. These are on Thingiverse if you want to go and play with them. Carbon fiber reinforced nylon for the spokes and the hub, and then the actual surfaces that would wear a normal nylon because that's a better material for that place. Like CAD needs to change, and we need to develop better formats for communicating this data and information.
So the one thing I'm wondering about, is you saying CAD needs to change, but I'd also assume CAM and slicing would need to change a lot for this to work, especially if you're mixing and matching additive and subtractive tools.
I think all those things need to become one thing, and we see that already.
Are you want to bring back Skyneforge?
Pardon?
Do you want to bring back Skyneforge?
No.
Okay, thank you.
Look at Fusion 360. It's got CAD, FEA, and CAM machining all in one workflow. And that's really useful if you're machining parts. We need that for additive. And we need that for additive for designing entire additively built products and processes such that we can build products and build entire products and throw them off onto conveyor belts and design them. And the CAD needs to have knowledge of, for example, when you model a cube in CAD, it just sees a cube. But actually in FDM, you've got shells and infill, and it doesn't know any of these things. So when you FEA it, it's total nonsense. So we need you to connect all those loops together so that the FEA in Fusion 360 can FEA a sliced part, not just a part. And we do generative design with toolpathing,
but that's not what you're working on. That's for someone else to solve, I guess.
Someone else.
Yeah. So you're working on the hardware. How are people gonna get that? Because this.
It's a bit weird.
I feel like this is a bit harder to integrate than just plopping a V6 on any printer.
Yeah. This is a non-trivial product. So what we are selling at the moment is a pre-order, which is £100, and that gets you in the queue.
Tesla model.
Yeah, exactly. Just like the Tesla Model 3, except $1,000 is $100. £100 anyway, 100 units of money. Then when we figure out how much it's going to cost, which we think is about another £1,000, we will send you this machine with no electronics and no tool heads.
So it's the equivalent of a bare bones PC, I guess.
Yeah, exactly. And there's method in that madness because Duet supports this beautifully if you build your own macros. But also we're talking to the guys who do Redeem, and they want to support this. And so we want people to be able to select electronics and upgrade them.
And mix and match, basically.
Mix and match and support. The other part of the method in the madness of not supplying any tool heads is that everyone has application-specific needs. If we just supplied it with a V6 and a brass nozzle, and you want to print carbon fiber, well, it's a waste of money. So buy the tools separately for your purposes.
When is that going to be available? Do you have a rough estimate for that yet?
I think we're in the kind of 3 to 6 month scale.
This looks like a good functional prototype. It's just a typical issue of needing to manufacture it somehow.
So we're going to go through a kind of beta phase where you need to build the second machine, which uses the big fat high wind rail and is basically DFM'd a lot better and DFA'd, designed for manufacture, designed for assembly a lot better. And so that's going to be tested. and then we're going to make like 10 to 20 and send those out to people we trust, who will provide us good feedback and tell us if anything is wrong, because we like to do testing at E3D and verify that the products work. So people like yourself, we would love to send you one.
If only I had the time.
If only you had the time. I would love, maybe we can lend you one that's already set up and you can experience it.
Oh, we'll look into that.
Yeah. Come over and visit us. You can pick one up.
Is that carry-on size?
No, it goes in a special box, but it is small enough to FedEx. We can FedEx it. But anyway, the beta phase, we'll get the feedback, we'll check everything's legit, and then we'll go into full-scale manufacture.
Okay, so that is one way to get the entire setup. Is it going to be open source? Are people going to be able to build it themselves?
Oh, hell yeah. I mean, the objective here is not to create a printer, it's to establish a standard and to prove a concept. So we have Lulzbot are interested, BCN3D are interested. So we want to create an open standard for interchangeable printheads, so that you can take a printhead made by E3D, put it on a BCN3D machine, buy a Lulzbot machine, take that same head off, put it on over there, open source, interchangeable. We need to set that standard. That's going to take effort and work, so we need to break the chicken and egg problem, and this is that. This is the first step towards that eventual goal. I know it's not just that we'll release drawings, we'll release the Fusion 360 CAD, like the actual legit CAD files, so you can actually get in there and play with it.
And I guess you're really excited about this. I am too. Like this could be so much more than just FDM 3D printing right now.
Yeah, this is not about FDM. This is beyond FDM printing. I love FDM. I'm like a mad FDM nerd. I love it.
But this is a manufacturing platform.
Correct. Yeah. This is about producing products without any human labor. Additionally, a lot of feedback. A lot of people have told me that they want to just buy the grabber and the plates, and so we're going to sell those as well. And those should be really cheap. So the grabber should be like 30, 40 pounds. And
so it's to integrate into your own products, into your own machines, I guess.
Yeah, so people can build their own machines that do tool changing.
Yeah.
And
it's going to be awesome.
Yeah.
It is going to be so awesome.
And it's cost effective, it's lightweight, it's small. And it's reliable.
And it works.
It works.
It works.
And it's got 3 micron repeatability.
That is awesome. All right. Thank you so much for your time.
Dude,
appreciate it.
love talking to you.
And
You're welcome anytime.
I'll give you guys a visit.
Awesome.
And to end this video, thank you again to Matter Hackers and Ultimaker for sponsoring this video. Stay tuned for more content from Murph 2018.